Hop into business as usual. There is a photographer here tonight for Google Fiber, so if you don't like your picture taken, look this way. But yeah, so just a heads up for you guys, letting you know that there is a photographer here tonight. Cool. Well, welcome guys to GDGKC. A lot of new faces in here, so welcome. A lot of old faces. Happy New Year. To start off with, if you don't know me yet, I am Kyle Paul, and we have Vince Garcia and Jay Whitsitt. We're the organizers for GDG Kansas City. If you have any ideas for topics you'd like to see throughout the year, or sponsorship opportunities, or you want us to branch out to another venue, let us know about that too, because we're not married to Google Fiber here. We love Google Fiber, but we're happy to move to a better location in Kansas City for a meetup or two. Here's obviously you guys found us somehow, but here's all of where we are at. Google Plus, Twitter, Facebook. If you want to send us a message, we monitor these accounts, so we'd like to hear from you guys. Meetup.com. We also have a GitHub, stuff like that. DevFest Kansas City. So this is our annual conference that we have coming up. It's going to be pretty awesome this year. February 20th, so put it on your calendars if you haven't already. We'll be at the Jack Reardon Center, which is
KCK intersection Minnesota and 7th Street, where the 7th Street Casino is, a little north of there.
So that kind of general area of KCK. We do have a fancy little discount code here for you guys. If you would, ticket prices are $30, $25 for students. This will knock off $10 for you guys because you're here tonight. This code expires, I want to say by Friday morning, I want to say. So, and then it'll roll back to just $5 off. So if you, this is a special for you guys here tonight. But yeah, so we have that. And this is our, for those of you who don't know GDG Kansas City, all of our events are free and to the public. This is the only one we charge for, and that's just to kind of, we're bringing in so many speakers. We have 15 on the list right now.
That's it right here.
From Mozilla. We got Roger here. So yeah, we have a bunch of speakers coming in from local and afar to bring you guys some really cool stuff, and so we're really excited about it. So there's that, and then again, like we did last year, it was a pretty big hit. We did Android Study Jam, which it was last year was more of like an intermediate level. So this year we're kicking it back because a lot of you guys dropped off in there because it ramped up really fast. So it's a little bit more beginner friendly this year to kind of easing you in to Android development. And so kind of what we're looking for you guys today. Last year it was an 8-week course that we did. It was once a week. But this year we're thinking, we want to see what fits your guys' schedules the best. Is it 4 to 5 weeks, so once a week would work for you guys? And all day Saturday, everybody kind of get together, jam, learn about Android development, or 2 half-day Saturdays, which kind of works. Go ahead and shout it out or raise your hand on one of them, because we're open to whichever would fit your guys' schedule the best. So
you're gonna make an online poll.
We do have one on our Google Plus. We've had 3 votes on it. So that's why we're bringing it up again.
Google Plus.
So, I think we set it up a Facebook poll as well. So we have a Facebook poll and a Google Plus poll going. Twitter doesn't have polls that I know of. But they do now?
I think they have voting.
Voting? Oh, okay. So, we do have it on Google Plus and Facebook, but we're bringing it here again because we've only had 3 votes. So, and right now it's neck and neck across the board. So whichever format fits you guys, go ahead and let us know. Because we're happy to adjust to whichever one's the most popular and still bring you guys this content. Cool. Then lightning talks. We're going to do a quick little intro here. Anybody, let us know what you're working on. Anything that you've recently learned that you kind of want to. You don't have to come up here. You can just, from where you're sitting. Is there something cool that you recently learned technology-wise, or something cool that you're working on that you'd like to talk to everybody about?
Hi, I'm Janice. I'm with Mozilla. And I just wanted to come and announce an exciting new project that we're doing here in Kansas City with funding from the National Science Foundation, which is try to take this some of the cool things going on in tech innovation using gigabit technologies and bringing that into classrooms here in Kansas City. So we're looking for people who either have project ideas to apply for grants to pilot those in learning environments, whether that's a school, a class, a library, or a museum, or people who want to contribute their tech skills to educators who are looking to run these projects. So if that's at all interesting to you, come find me afterwards.
Very cool. Thank you. So, if you would like to know more about this, like she said, come reach her afterwards. But she will also be at DevFest KC as well with a whole session diving in more about Hive KC and what Mozilla Foundation is doing here in Kansas City, which is really awesome. So we were talking about it beforehand.
HiveKC.org.
Yes. So very cool. Anybody else? Share something cool that they've been working on lately, or? No? Cool. I guess we'll go ahead and hop into solid development.
Okay. Hi, I'm Jay Whitsitt. I am an iOS developer, but have done a lot of just kind of mobile architecture work and some other development stuff separate from my iOS development. So today I'm here to talk about solid principles. I first heard about this a couple weeks ago, where some contract workers that work with me at the startup I work for, they were like talking about some stuff and mentioned solid, and I thought, what is solid? Like, it sounds like one of those buzzwords that you hear all the time, agile, any buzzword that just kind of comes and goes, and people think they do it, but they don't really do it. So I kind of decided to figure out what it is, and hopefully I can share some information that I learned along the way. So as a developer, a lot of times we just kind of get thrown into something and just think that we can develop all the things and try to do it as quickly as possible and move on to the next thing. But really, there's a lot that you can do to improve your programming with different software design principles. And that's kind of what Solid helps you understand. So there's a lot of different kinds of programming principles out there. These were just some that were on Wikipedia. Of course, there's a lot more than this. And you can see that Solid is actually one in the S's. So Solid is an acronym and stands for Single Responsibility, Open Closed, List-Up Substitution, Interface Segregation, and Dependency Inversion. So there's a lot of content in some of these, some more than others. So if you have any questions along the way, or want me to slow down or explain something a little more, just let me know and I'll be happy to. So the first one, single responsibility. Essentially every module or class should have a responsibility over a single part of the functionality provided by the software, and that responsibility should be entirely encapsulated by the class. So basically, if you have a knife and you just want to whittle away at something, you don't need to necessarily make this Swiss Army knife of everything in this one class. It makes things more complicated. If someone has to change something later, it can be confusing for someone to read it. There's lots of different reasons. So one example is, say you're wanting to code something that deals with geometry. So you have a rectangle class, and we all know a rectangle has a height and a width. It has an area, and maybe you want to draw something. So one way to kind of separate the responsibilities a little bit, you really have two functions that you're trying to do with this one rectangle class. You need to calculate the area and also display this rectangle in your UIs out. So this is very similar to MVC, if you've ever heard of that model view controller, where you have your data, your view, which is separate, and then your controller, which kind of handles the data within the view. So one way you can do it is make a rectangle shape and a rectangle draw class that would handle the individual functions. So that one's pretty straightforward, just single responsibility in each class. Any questions about that? That one's the easiest of all these. So, okay, so open closed is kind of the next one. Software entity should be open for extension but closed for modification is kind of what this wants to say. So this kind of has introduces interfaces and abstract classes where you kind of build off of classes that you've already created. So like in the picture, like the human body is the human body. Most people have 2 arms, 2 eyes, a head, 2 legs. And if you want a coat, there's kind of a standard set of sizes that you get. And the coat is built off of the principle that human bodies are generally the same structure. So you don't need to necessarily modify your body in order to buy a coat. So in coding, if you wanted to calculate the area of the rectangle class that we already made, so you create an area calculator class which has an area method, and so you say if it's a square, if it's a rectangle. That will work. However, if you are going to add a circle or a triangle, you're going to have to create a triangle and a circle class as well as modify your area calculator class. So it'll work perfectly fine. It's just a little more difficult to modify and extend it in the future. So one way that you may think to do this is to create a shape abstract class. So every shape has an area, can have an area derived from it. So if you create your shape rectangle and extend from the shape, it says that all shape classes have to have this area method so that each individual shape can calculate its own area, because it knows for a rectangle it's height and width, for a triangle it's base times height divided by 2, for a circle it's whatever that thing is. So yeah, any questions about that one? Open and closed and single responsibility will also go hand in hand a lot together. So if you're following one and thinking about one, it's usually pretty easy to also do the other one with these first 2 anyway. Okay, so the complicated one. So list out substitution. Functions that use pointers or references to base classes must be able to use objects of derived classes without knowing it. So simply put, if you have a base class and then you derive some other class, so you have the shape class and you derive a rectangle shape. Anything that uses the shape class should also be able to use that rectangle class, the rectangle shape class, and any other class built off of the shape interface, essentially. So kind of restating it, I'll actually skip that slide because it's kind of hard, but so if an apple is a subtype of a food, then you have a method that's eat. So if you're able to eat any kind of food, then you should be able to eat any apple. Makes sense, right? But it's important to note that the reverse is not necessarily true. If you can eat an apple, that doesn't always mean that you can eat any kind of food. Because you may be lactose intolerant or whatever it may be. And another important thing to note is that it also must work, which will actually lead to my next slide. So sticking with the geometry, so you have a rectangle shape class already created, and you add a square shape class. So a square is really a kind of rectangle. So at first thought you may think, well, why not just create a square shape that extends the rectangle shape? The problem with this is that the behavior of a square does not necessarily reflect the behavior of a rectangle. So if you change one side of a square, it also changes the other side because they have to be equal. But for a rectangle, that's not necessarily true. So if you were testing your code, as we all should, and you set the width and the height for your rectangle and you calculate the area, the width and the height should always equal the area calculation you get. However, for this square shape class here, if you were to set the width and then set the height is the only thing that's going to stick. So the width that you set up here won't be the same width. So this isn't following Lipscott's substitution. Does that make sense? Okay. Okay, so another example, I'll show you how to fix it later, but another example is a bird. So if you're going to create a bird class, at first thought you would think, it needs, and this is going to plot the birds on some map. So you need the kind of the XY coordinates and then also the altitude of the bird. So you'll need longitude, latitude, and altitude. However, so that works fine with a cardinal, which can actually fly, but if you have a penguin, penguins don't generically or usually fly. So the altitude isn't really necessary for the penguin. So what do you do? Well, the first way you can do it is create an if statement. So if you're going to arrange these birds on the map, you can say in a statement like, if it's a penguin, it doesn't need an altitude, so I'm just going to put it on the ground. If it's an emu, I'll put it on the ground because it also doesn't fly. But anything else, it can fly, so we'll put it in the sky. But this is actually a violation of the open close principle because when you create a new class, like an emu, you're going to have to go back and edit this class. So it's not closed for modification. That part makes sense. So the second way you can do it, and it works, it's just not quite as elegant. So in your bird class, create a new property that is flightless. So if it is flightless, then you'll go through one route, otherwise go through the other route. However, it still doesn't solve the issue where you technically have a property on this class that doesn't need to be there. So it doesn't really fix the underlying issue. So the correct way, in order to follow Lipscott's substitution principle, is to remove the altitude altogether from the bird class, because you know that not all birds have an altitude. So at the very lowest level, the bird class shouldn't have an altitude at all. And then create a subclass of the bird called a flying bird that would have an altitude. And so now your cardinal can be a flying bird and penguin can be the base class bird. Any questions? Okay. So that was kind of the first part of this principle, which was build based on behaviors, not necessarily physical characteristics. The second part, and there's actually several parts, which we could go talk for the rest of the day about it, but I'm only going to go through a few, is pre and post condition rules. So a precondition rule is basically something that has to be true or false in order for your method to be called. Right there. So a post-condition rule is the opposite. So something is true or false after your method is called. Or only here, sorry. So with list-box substitution, a precondition can only be replaced by a weaker precondition, and a postcondition can only be replaced by a stronger postcondition. So if your bird class, and then you create your flying bird class, any preconditions that existed for your bird class can be replaced by weaker preconditions in your flying bird class, but they cannot be replaced by stronger preconditions. And this will make a lot more sense in the next slide. So for the rectangle, a precondition for a rectangle is height and width must be positive, and the height is different than the width. So, makes sense. But for a square, it's the height and width must be positive, and a square they must have the same height and width. So that's actually a stronger precondition than the rectangle's precondition, which is the height is different than the width, which is the reason why it does not follow list-box substitution. Does that kind of make sense? So, and it's similar with the postconditions. When setting the width of a rectangle, the height must remain the same as the initial height, because the width and heights are independent. But then with the square, when you set the width or the height, it changes the other one. So that's a weaker postcondition. And the rule says that it can only be replaced by a stronger postcondition. Make sense? Any questions about that? That one's a little different to graph at first. I think, yeah. So that's kind of that one. So contravariance and covariance rule, it's very similar to the precondition and postcondition rule. It's just kind of stated differently. So with contravariance, arguments in a method defined in the derived class must be equal or of a less derived or more generic type. So say you have a calculator and it takes a string. Well, if your derived class, your subclass of this base calc, if you have the same method, it can take a more generic type of object, but it can't take a more generic type, which is just a generic object, but it can take a more specific type than string. Otherwise, it would break the principle.
So what would be a more specific type, like a string with a certain length?
Yeah. So, right. Because like if in here, say that, I can't make this specific example, but this can accept any length, but then this one requires a length of 5. If you were passing an instance of this class around to some other class, and it was just expecting any a base calc class or any subclass off of it, this is requiring a stronger type. Does that make sense? Yeah. So it may end up breaking something, it may not. It may work fine, but for it to work in any situation, it would have to be a more generic type. Yeah.
So if you have a class that has an enumeration on it, and the class is using an interface, and the more detailed components of that parent class have, like, let's say you've got a series of providers that do magical stuff, and then they all do it on this magical entry item. So you give it an entry item, and then it has an enumeration for the different types of entries, and then the providers operate under the enum, and they do casting based on that enumeration. Is that a violation of this principle, or does that sound? Because alternatively, you end up having to create a bunch of interfaces in that situation where you have your generic type that you want to cast to more specific types within the providers, but you want your interfaces to use the higher end types. Does that violate the principle to do that, or is that still within the original planning?
I think I follow what you were saying. So, let me repeat it to make sure. So you have a class that's accepting a generic type, but anyone can give it a more specific type.
So let me give you an example that will actually make more sense. Let's say you have an oven. Let's just make real items here.
Sure.
You have an oven, and then underneath that you have different types of ovens. So there's different like brick ovens, and then there's other components of ovens. Now what you're passing to it is food. Now the implementation of, like, let's say you've got pizza in the brick oven. The food item says I'm this type of item based on an enum. So like I have a brick oven, I'm brick food of whatever type of oven specifically is there. And then when you pass it to the individual oven providers or implementers, you then cast that to the brick cooked food. You cast it to that. Does that make sense? It's kind of hard without a whiteboard, unfortunately.
I think so.
Is that a violation of the principle, or is that?
So by casting, I think what you're doing is breaking the open-closed principle, because if you then created a different kind of oven, you would have to then edit this class that you created.
Well, you wouldn't, because you'd be able to. So like, let's say you created. So you'd still be able to pass food to the new provider, because the enumeration is going to control which provider you're sending it to, which oven you're sending it to, in this example. So you can send food to different ones, but the provider needs the specific implementations for those specific components. So basically, if you put the enum incorrectly on that item, then it's going to fail, but it's still isolated in that respect. Because alternatively, you end up creating an interface per oven, which is going to create less reusability.
I think, if I'm understanding you too, you have your oven base class, which, you shake the mouse, maybe. You have your oven base class, and then you're extending your brick oven, your electric oven, your gas oven, and then you have your food base class, which pizza is a subclass of, and then you're taking that pizza subclass and passing it into one of the subclasses of the oven, I think is what you're asking.
Correct.
Okay.
Well, you're passing food into the oven, and then the individual brick oven is actually cooking the pizza.
So you have an instance of a brick oven, and you're passing in some food.
So you're passing in an instance of pizza that inherits food, but you're sending food to the oven.
Yeah, it's served from two different base classes to two different
So
subclasses.
the oven doesn't care what actual food it is.
The oven does not care, but the brick oven does care.
So I think that's actually going to get to another principle.
Okay.
I think that example is, I think I'm getting lost because there's two sets of abstractions and I'm like confusing them.
Yeah,
So I think that will work, but
Because they're two different.
wait for the
and it
class.
gets way more. Like, there's a specific implementation that I had to deal with. I had to do very something similar, but it was with things that are way more complicated. So,
maybe like afterwards I could
Okay.
sit down and help you with that specific one if you want. Okay, so any questions about that? With contrary specifically. So on the other side of it, so this is kind of like a precondition. So in order to call this method, the precondition is you have to have a string, and you have to have an object. So on the other side, the postcondition is kind of like the return value. So So the covariance rule is return types of methods defined in the derived class must be equal or of a more derived or narrower type. So if your base calc class takes an int, then anything derived from this base calc class has to be of a narrower type. So a short is shorter than an int, which is why this works. So if these were flipped, if this took a short and this took an int, this would probably pass something back to this parent class, so then you would lose some precision, and who knows what you get. Make sense? Okay. So that's all for list copy substitution. Any questions about any of that? Okay. Interface segregation, which this actually may help your question with the pizza and ovens. So no client should be forced to, sorry, I think it's the next one, not this one. No client should be forced to depend on methods it does not use. So if this doll requires food and he wants to eat food, he doesn't want to have to light a candelabra, lay out cutlery with Whitsitt layout because he doesn't care. He just wants to eat food. So imagine you're at an ATM. ATMs do a lot of things. So a lot of things in succession usually. So it's going to display something when you're coming up to it, ask for your PIN, tell you if your PIN's wrong, ask you how much you want to withdraw, tell you if you're broke, and then spit out some money. Maybe. So for solving this, for like the user interaction piece, you can have all these different methods. So they're all dealing with user interaction, but they all kind of deal with different parts of user interaction. So ask for a card, invalid card, ask for a PIN. So there's kind of some card-based ones. Ask which account, not enough money in the account, and like tell you your balance. So there's kind of some very obvious breakups that we could do. So you could break it out into, when you're logging in before you have access to any account, which would be good for security reasons, for one example. And like if you're withdrawing something, so any of the withdrawal methods, along the same lines, any of the deposit methods, that kind of thing. So if you're creating an English messenger, it could implement these specific interfaces. One other way to do it is like if you have methods that should be called when you do have access to an account and methods when you don't have access to an account. So you may have one class that is like initial login screen. Well, it should implement the login messenger, but it doesn't care about the other ones. Whereas if you had this interface, it would have to implement all of these methods when it doesn't and shouldn't for security reasons. Does that make sense? Any questions about that piece? So still on interface segregation, if you were going to implement your bird and flying bird differently, you can implement it as an interface. So a cardinal class would implement the interface rather than just directly set class from it. So you might have an eat, walk, chirp, and fly. Well, we've already agreed that not every bird flies, so that's probably not the best way to do that. Instead, you can, and forgive me, I'm not a Java developer, so if there's any Java that's wrong, don't hate me. So you would essentially create an interface that extends off of the bird that adds the fly method. So a penguin can implement off of the flying bird interface instead of the bird actually that's reversed. It should not implement the flying bird. It should just directly be bird, and a cardinal gets the flying bird. I even went through this several times looking for typos.
Or you could have just changed it to travel. All birds travel.
Yeah,
Some fly, some walk.
yeah.
That's how
Okay, so any questions about interface segregation? So kind of to sum it up, the base class should be as low level as possible and build off of that.
Sounds a little bit like more like NBC with
Yeah,
it's a separation of concerns. And
yeah,
Let's take the design principles and try to make them more clean code.
yeah.
Some design principles session yesterday, so through a few of these.
So dependency inversion. So this is the last of the 5. So it's kind of in 2 parts. The first one is high-level modules should not depend upon low-level modules. Both the high and low level should depend upon abstractions. So I think this kind of goes to, and you'll see it in the example, but with your example where the oven and the pizza both have layers of abstraction. So like the oven should take a food and not directly handle the pizza. But then there's like a brick oven food, like a better in a brick oven. Yeah, like a better in a brick oven food kind of interface that the pizza could then reference off of. And I'll explain a little bit more.
You just end up with a lot of interfaces when a single
Yeah.
class isn't doing it, and if you have to serialize the objects anyways, I don't know that you get any benefit.
I'll come back to the example when I'm done with this one. So the second part is abstraction should not depend on details. Details should depend upon abstractions. So one example of this in our everyday lives is a wall outlet. So the in-wall installation of the electrical work doesn't really, I mean, it probably should care because you don't want to blow your house up, but doesn't necessarily need to care about how your wall plug is designed. And the reverse is true. Your wall plug doesn't necessarily need to know how your in-wall installation of your electrical work is done. Both parties have agreed upon the interface of the 2 vertical prongs and 1 hard circular prong. So, say you want to create a simple copy function. It just copies from a data source and outputs to some output source. So you could start with just a simple copy, and it reads, it takes an input, reads from the standard in, and if it got anything that wasn't in the file, then write it out. However, if you're going to add something like write to printer or write to disk, you're going to have to modify this copy method every single time you add anything new. So like this copy function takes an output device, and if it's the printer, do this, else to disk. We don't want that because that's updating 2 classes at the same time, and you don't necessarily need to do that. One other thing is that it creates a dependency. So this class that this is in would need to know what to do when it needs to print to the printer. Each printer, like a Canon printer, a Kodak printer, they all may do something different. And same with this. So you're not creating dependencies in this one class that these other methods in this class don't necessarily need, and it just makes it harder to go through your code, find bugs, that kind of thing. So by creating some kind of common interface that can be passed in, it kind of up. So really there's 2 things that we're dealing with, the reading and the writing. So let's create an abstract class that is the reader, and an abstract class for writing. And so you can create a concrete class that's keyboard reader that implements this read function, and a printer writer that implements the write, and you also have like a screen writer to see it out. So if we have these, we can modify this existing method. So this is what it looked like before with all these different agents, like screen writers and somewhere down here too, to look a lot like our original implementation, which was it takes a reader and a writer. If you've got anything for reader, then write down. So it doesn't care what the actual implementation is within those classes. It just knows that it has a reader and a writer, and it's not dependent on the details. It's dependent on the interface. So, okay. So I think I can answer your example much easier now. So you would, in order to follow this, and I'm not saying you should, the way that I would do it is you have a food interface or a food subclass or something, and then you have a brick oven food class or interface that the pizza is then derived off of, so that the brick oven class only takes a brick oven food object, but not necessarily a base class food object.
But in order to get, like, in order for your oven, your core oven, to get down to the bake oven, you're going to have to you're going to have to show the item, and that's where you get into the issue. As opposed to having the brick oven cast the food item, cast the brick food over, because if it doesn't cast a brick food, it can just let it go and not accept that as an input, and just say, either throw an exception, or just handle it gracefully and say nothing. Because you do get locked into implementation, which can create problems maybe for mock testing. But I don't see any other disadvantage other than if you've got that enumeration and then that enumeration essentially mapped to the class type. I don't know that it creates a problem. That's what I was asking, if this has any method to really address that specific scenario where you have, because there's lots of food and there's a finite number of ovens, but potentially more ovens that are going to grow over time.
Sure. I think it would be just like an interface on top of an interface. So it's where, like, this is an oven, and it takes any food. And
you might say object. So it says the object should be the one, the food type. Is anything other than that will just extend the top of that? So we don't want to restrict it to a lesser object.
I don't know. We can talk afterwards. Well, so what did you say?
Oh, no, I was just saying with that example, the food would be the object.
Yeah.
Then the base oven thing would be the string and so forth.
I'm not really sure.
Just have the base take the enumeration. Then you're just adding to the enumeration.
Yeah. But the whole point of this is to not add to, to not have to modify the implementation of other classes that take interfaces.
It's not an example.
Yeah. So actually, my last slide says, or maybe it's just my notes. Oh, it's just my notes. So, so these are principles, not necessarily rules. The one thing that I hate more than anything is someone standing in front of someone and saying, like, you have to do these. So that was not my intention at all. But these are just kind of guidelines to use that generally help keep your code cleaner and make modification and extension later a whole lot easier, especially if you're on a large team. Part of your team is like on the other side of the world. So
You're not having to refactor later.
right.
Code rewrites.
Yeah. Any other questions? Yeah.
So sorry, I had mommy mode going on before I could get here. So are you sharing your pitch deck?
Yes, I was going to. It'll probably be on our Google Plus page, right? We can just paste links from Drive to that. Can't we? Yeah. So it'll probably be cross-posted on our other social media, but it'll definitely be on Google Plus. Any other questions? Thank you very much.
Could we try that example on the projector?
Sure, yeah.
Right a full app.
Pull up.
Material design. So I'd say a little under half of you guys raised your hand for that. So it's still a little new, still coming out. What material design is, Google announced it at I/O in 2014. Kind of is a whole kind of revolutionary thing because how many are Android users in here or have used an Android product? Okay. So you kind of know that in the beginning days it was kind of not as pretty, but it was very functional, right? So one thing, Google overall went back and they got a bunch of design geeks together and really kind of sat down to develop a new design language, which codenamed was Quantum Paper, but all of us know it as material design. And it's based upon the paper and ink concept, where a physical design elements, because you have pieces of paper, ink that writes on top of it. It's a 3D representation on a 2D screen, is what they were going for. The goals of it to create a visual language that synthesizes classic principles of good design with the innovation of possibility of technology and magic. So kind of like taking technology and web or mobile to like the next level, kind of showing how when you do something within an interface, you have a reaction as well. It's not just changing the screen. There's something that happens between the user deciding to click a button and that next screen that happens. So that's kind of, they were trying to explore, like if you were, I guess, a real world example, you're reading a magazine, you turn the page, think of like that page scroll kind of thing. There's that action between you get to the next story. So something like that, but in a full interface, not just a page turn. Cool. So there's three big parts to it. You have material, but within material design, everything is called material. So a button is material, a toolbar is a material, an icon is material. So when you're reading through the design docs, that's kind of one thing that's a little confusing at first because they keep calling everything a material. So you're like, wait a second, that was a material. But that's kind of really how it all, those are just the elements that are part of it. And then the other part of material design is that it's bold, graphic, and intentional. So when you're designing an interface layout, this in material design is known as a fab, an action button that kind of put out front. It's kind of, it's there for a purpose. So when you're looking at, if you have the Gmail app opened up on your phone, for example, you have that little fab down in the corner, that's where you start a new message from. So that's the intent. It's there. That's the action that the user is going to take. If you have, and then you have your menu button in the top left, and that's what's going to open up the side nav, aka drawer. So those are actions that are out there in front for the user. So it's bold, it's intentional. The last, whoops, whoa, that was fun. Don't do that again. Where did my mouse go? Okay. So the last part is motion. So this is signifying motion. So motion is intentional. When there's a transition that happens, when the user clicks a button, there is an intentional motion that gets put into place. So when you, for example, you click that the menu icon in the top left, when you click that, that's going to cause the side nav to come in over top. So there's an intention for that motion. The other part is sometimes you don't catch it all the time when you're playing with it on a mobile app, but when you click that button, there's a little ripple effect. So that ripple effect that happens, that's showing it's like a response to the user that you clicked it. But the other part of that is you clicked it on this specific part of the button. So if I were to use my mouse on a web interface and click this tab, it would ripple out from here because I still clicked it. So traditional interface design, I'm more of a web developer, so my examples will kind of gear more towards that. So if you're dealing with Bootstrap or other CSS3 effects, when you try to emulate that ripple effect, no matter where you click this button at, it's just going to ripple from the center. Because that's kind of, we've seen that on sites everywhere. I mean, that's just what's happened. But with material design, it kind of adds in that extra interaction and, what's the word I'm looking for? It's the user has that gratification that I click this button here. If you're in a list view, wherever you click in that list view, it's still going to perform that action, but that user has that gratification like, I clicked it here, and it's going to ripple effect out from there. So that's there's a purpose for that motion. So that's one of the other things when you're designing an interface with material design, that motion that you're adding, well, a lot of these materials have motions built into them, but certain materials, you give a motion, so like that side nav that comes in, you can make it come in from the left or come in from the right, but it has to have that purpose. So if you have the menu button over here, you're not going to make the side nav come in from the right, you're going to make it come in from the left, because that's smart placement and purpose of that side nav. And if you're going to have it come in from the right, you would have the button over here on the right to cause it come in from the right. So placement of it, of the material before the motion is also key. And stop me if I ramble on or if you have any questions or whatever. So.
Is there a library that exists for using this?
We'll get there. Yes. Short answer, yes. Click. Okay. So of material items, these are the core parts of material design. The parts that us as developers and designers, so these are design elements for developers to design interfaces. So whether you are, your core, job function is to design interfaces, or as a developer trying to build to an interface, these are the things that, with material design that you get. So with color, you have, there's a massive color selection that they've kind of designed this color library set up for you. So that's, I'm only showing a few of them here, but with material design, you can go to the short URL and kind of, it's massive. There are a lot of colors in it. You have all the different hues, but what's interesting in material design is you only get 3 colors, because that's kind of the way that the design language is set up. There's, you have a primary color, an accent color, and a worn color. You do get a black and a white for background color or text, your font color, but for material colors, for other effects like that, you have these different hues that you can play off with. And what's fun that's built into the material language, Google will, if you're using the theming providers set up for in the libraries that are available, it'll automatically, based on the color that you pass into it, will change the font color. So that fits more appropriately with that color. So if you're using a darker color, obviously black font won't work. Well, you can still do it, but it's not as readable. Whereas if you're using a lighter color, it'll auto change it to a darker, to the black font on a lighter background. So that's, if you're using the libraries, it's really, really cool for that.
Is that SAS pre-compile, or is that done on the fly somehow?
Depends on the framework.
Okay.
But yes. So yeah, it kind of depends on the framework, but yeah, it's kind of provided for you.
Okay.
So cool. And then Google thankfully spent millions upon millions of dollars developing this font, and we get it for free. It's called Roboto. If you've used Android since I want to say, was it KitKat? Maybe. What's that? Lollipop? Was it? Okay, so Lollipop is when they started using Roboto as your default font for the Android OS. And so what's really cool, if you're developing on an Android app or a web app with material design, Roboto is your default font as well. And with Roboto, it's that. It blinks a lot actually. You have these different pre-built-in properties of headline, title, subheader, to where it auto gives you those font sizes, those point sizes. So that's kind of cool to where within your interface you can define, I want a headline, and it already knows it's going to be regular 24 point. So you don't have to set that up in your CSS styles, for example. You can just, those classes are already defined for you. So it's a really cool part from the theme that you get automatically out of it. And then, I'm trying to think what other. So yeah, kind of like I said, material design handles the topography for you. You can add more on top of this. This is not saying what you have to use, and you can override these as well. But this is the defaults that are given to you. So when you're developing an interface, you just reference them and you're good to go. So no extra code there. The other part is layout. So this is what I was kind of talking about, the 3D interface in a 2D plane. Obviously on our mobile devices, it's a 2D screen. On a web device, it's a 2D screen, so it looks like this. In reality, it uses your z-indexes to kind of how everything gets layered. So you have some, and also to represent that, material uses shadows based on the depth of the z-index. So obviously when you're developing, you're not going to be putting your button, on the first layer, because it's going to be covered up by this card right here. So you're going to have, so as you're writing your interface code, you think about the placement of these items as well. So how you're developing your layouts. So for that, you have your three representations of that layout, kind of showing how that kind of stacks up and builds a positive story. I can go a little bit more into depth on this if you guys have any questions on it. But if that kind of makes sense on how it's kind of layering on top of each other. So the part of the core design is stacking your materials. And the placement of those materials, how they get stacked, is that part of that bold and intent. So it's intentional where that placement is. Oops, went too far. So, and then the other part is motion. So with motion, if any designers in the room, you know what easing? No design? Maybe? I got a head nod. Okay, there we go. Cool. So easing, what that is, it's the action of the motion, to where it starts out fast and then it slows down, eases back out. So that's with the motion that you add into your app with material design. When you see it start out, it's going to, you'll see that ripple start out, and then it kind of dissipates out. So think of like dropping a droplet of water into a pond. You see the ripples start out fast, but then they slow down. So it's kind of the same kind of effect. If that helps make a little bit more sense. And here's a little example. So part of that motion is the responsive interaction. Is that too dark? Oh, you can see it on that. Is it not on that? I guess you can't really see it on the middle screen, but if you look at the two side ones, you can see where you're tapping one of the list items, You can see kind of how it does a little ripple effect based on where, so yeah, 3 just got hit in the middle, 5 just got hit on the right, 1 gets hit on the left. So you can see how the ripple effect is going out from there. So that's the motion mixed with the responsive interaction. So you're getting that responsiveness from the interaction with the device. Did you raise your hand?
So I'm assuming that problem is because of the refresh rate on that screen.
Probably.
Is that a problem with the library too, though? If you have a low refresh rate screen?
This is actually the first I've seen it, so I can't say on that one. So I guess possibly. I would say it's part of the screen.
I think the
colors are also different on that screen.
Right, yeah.
I think it's the color and the contrast on that.
You can see the line moving, but you can't see the gray shape.
Well,
It's actually happening, we just can't see it. I think it's
Yeah.
the color,
yeah, because you can see kind of where it darkens on the lines a little bit. But yeah, so to the screen effect part, I've seen it on an Android device where on obviously Lollipop and newer devices, it understands material design. But on an older KitKat Jelly Bean device, the material still exists. It's just the action does not. So that is one part of the material design library is that at least the official Google ones, they are respectively degrade themselves to where the material can still exist. It's just you might not always see like the ripple effect, for example, depending on screen and blinking, the screen and resolution. So that might, so the library does interpret that. Does that answer your question?
Yeah, I'm just curious if you would see that behavior on older systems.
So yeah, on an older Android device, I have seen that. So for example, for our DevFest website, I wrote an Android app for the DevFest conference on Lollipop and Up. It works fine, but then I happened to test it on an older Android device I had laying around. On the tabs on one of the screens, it doesn't ripple on an older Android device. The tabs, the materials still exist, but the effect didn't because it degraded itself in order to still represent that material. So.
I'm just curious what will happen if you just can't tell they're clicking and it's loading.
That is the library itself won't handle that, but so if you want that to happen on an older device, you would have to write that in. So that's the, it does degrade it. So like if you, with material design for web, I believe IE 8 is for one of the libraries, is the lowest that one goes. For the newer one, I think it's IE 10 is the lowest it goes. So, but again, it depends on the framework you're using. But with that, it will degrade itself to still represent the material. You just might not always have the motion or the action, or the responsive interaction. So that's kind of a the pro-con of switching to it. I mean, it's kind of trying to push forward, but you can't always bring everything.
It's time for people to upgrade for my
Yeah, please. So that's so you have the representation on the sides. You have a representation of the ripple effect. You have transitions. So if you were by clicking this, let's say you open up a new page, that transition is another responsive interaction on top of this ripple effect. So like I was saying with the drawer, for example, when you click that menu button and the side nav slides in, the side nav just doesn't appear. It has the slide in action, and then when the side nav disappears, it slides back out. Or you have a dialog box. A great example of a dialog box, when you click on a button that triggers that dialog box to open, let's say it's an edit icon, that dialog box, granted it's a separate material that never existed, but you click that edit button, it appears out of that edit icon. So you have that motion, that responsive interaction happening. And then you fall asleep. So that's just another, there's a purpose for that motion. It's coming out of that edit button. And then let's say you click cancel or save, it goes back into that edit button because that's you can use, you have reference to that parent to send it back where it came from. So that's some really cool things that you get out of the material library. Okay, so to your initial question, where do I start? So first, I would definitely recommend, before you dive into the other frameworks, because it'll make more sense, look up the material design docs. It's just google.com/material design. And then, but they also have, the iOS one is not official, but there is a material design library for iOS. It's built into the Marshmallow. So if you're developing any apps for Marshmallow on Android, it comes with material. You can also have, there's libraries for web components, like Polymer, which we've talked about last year, I believe. Polymer is another Google project. There's, Mozilla has one too, I don't remember what.
Sorry.
So yeah, there's other groups out there that have web component libraries. Polymer just happens to be the one that Google is running. And then also additional web frameworks. So for Android, these are the official docs for Android. If you want, if you're interested in using material design with your Android applications, the iOS one is a GitHub library that I found that a lot of people have been using for material design within iOS applications. Granted, again, you don't necessarily have to use material design in iOS, which if you follow iOS guidelines, material design doesn't fit the iOS bucket. But if you want the same cross-platform, you can use it natively with this iOS library. And Jay's over sitting, no. But yeah, so here's like a good example of how this fab is sticking out on top of you see a little bit of shadow right here. So it's like, this is a bold statement. This is what if you want to do a new email message or whatever, you start with this file. And then you see the other ones are kind of, so you have your menu, search, and I don't remember what the checkbox is for. But, so those are on like a same level playing field, so they're not sticking out and like, this is what you have to use. They're still there, but when you click on them, or tap on them in this case, it's still going to have that ripple effect to show that there's an action. And within this container, so this fab, you can click anywhere in this fab or on the plus, it's going to ripple only within here. It doesn't ripple forever. It's only within the container, the content that it's within. So in this list view, this list item, it's only going to ripple on this list item. So you don't necessarily have to fully worry about that. And then, so like I said, the web components, you have the Polymer project, and you have Materialized CSS. I've used Polymer, I've not used Materialized CSS, and there are a few other ones out there. I couldn't remember the Mozilla one, so that's why I didn't have it in here. But if you look up web components, you'll find some more. And here's, for other frameworks, Angular Material, which I've been using a lot. That hit 1.0 December, so it's production ready. It's actually pretty fun to use. I'm an Angular developer, so there's also, and that Angular Material is actually Google backed as well. Material UI is for React, if there's any React developers in here. Material Bootstrap. Again, that's an open source Bootstrap implementation of materials. So it's not, it still uses Bootstrap behind it. It's just using the material styles on top of Bootstrap. And then this is not technically for frameworks. I just didn't want to take up a whole other slide for it. But Material Design Lite is another one. I know Google was behind it. I don't know if they were fully behind it, but because other groups were part of it. But with Material Design Lite, it is framework agnostic. So that's a really cool part about it. You can drop it into any web. So if you happen to be using Angular, React, Node, if you're using PHP site, whatever, you drop in Material Design Lite. It's a very light version of it. You still get a lot of the same representations of the frameworks. It's just not, it's like with Angular Material, you can reference it as a directive. It's, I can't think of for React, or like, I guess you could call it a directive in Bootstrap as well. So when you're defining it with your tags, you can reference, or with your CSS class. So instead of calling it a class, Material Design Lite, you use it a little bit differently. But because it's framework agnostic, so it's not part of it. So those are some great resources there, and that's kind of what I had, because with Material Design, it's not exactly new, but it's still new, because if you look at a lot of Google apps, it wasn't until the end of 2015 when pretty much all of Google's products finally switched over to Material Design. So Google's still adapting to it too. It's just why I titled this for 2016 is there's all these frameworks out there now that are now hitting 1.0. So they're production ready finally, to where we can start using them. So that's kind of what will help push the web, push mobile forward in 2016. These libraries are ready for it now.
Has Foundation observed, or has Bootstrap given an opinion on it, or?
Part of the Bootstrap team was in on that one, so I know that there are, I want to say there's a few other Bootstrap-esque ones that others have created. This is the one that the Bootstrap team was a part of. So they do support it. It's not the definitive, you have to use it though. So yeah, that's, again, like Jay's previous talk, you don't have to use Solid. It's a great way of doing development, but like with Material, you don't have to use Material. A lot of places will still use Bootstrap. A lot of places will still use Kendo. A lot of places will still use homegrown UI frameworks. But Material Design is one that is out there. There's frameworks for it now. It's part of Android designs, so it's part of the Android design spec. So you're going to run into it. So that's kind of what this is all about. These are out there for you to use. So, any questions on Material or anything you'd like me to go into a little deeper?
You said you've been using a little bit with Angular.
Yes.
So I'm curious, I don't know if this is a risk or a benefit, but it seems like if a lot of companies adopt it, then probably the internet's going to start to look the same.
Well, that was kind of the same with Bootstrap.
Exactly. And
But
then people started to figure out how to kind of make it their own a little bit more. So have you experienced that in your using it, and how do you kind of tackle
These
it?
are just materials. They are not telling you, here's the template.
Okay.
So, for example, the Android website, Material. The Google Fiber website, Material. So, I mean, if you use Google Drive, Material. I mean, they have a similar look, but they're not the same. So, Inbox, if you use Inbox instead of Gmail. Gmail still hasn't fully adopted Material, so Gmail is still kind of its own little animal. I don't know if they're ever going to do it or not, but the Gmail app for Android definitely has changed. So that is with the obviously with the font. The reason behind Roboto is it's very readable on any device, any screen, any resolution. That's why Roboto. Amazon developed Bookly for all of their devices, so it's a font that's easily readable on any resolution that Amazon developed for if you're developing using the Amazon devices, or if you use a Kindle, Bookly is the font that it defaults to. So that's kind of, you will see a lot of similarities. You won't see everything the same. So you would, like, as in Bootstrap, you can theme on top of it. So like with, if you pull up that color map, like there are thousands of colors in there that are available to you. But as part of Material Design, you only have 3. You can do per theme. So you can have multiple themes in an app, but you can only have 3 colors per theme. So that's kind of the definition behind it. So does that kind of touch on, like not everything, you'll see a lot of the similarities, but not everything is going to be the same. Because like, if I go back here, so here, there's nothing in material design that says this fab has to be blue, it has to be in the bottom right hand corner. So this fab can be in any of the four corners. Obviously you don't want to put it in the top left because that's where your menu comes from. But if on a different designed app, it could be in the top left. So you will see difference in locations. It's still going to be presented, it's that bold interaction. So if you're using a fab, that's what you want people to use. That's where the trick is from. A list view is going to look like a list view though. But you can have 3 lines, 2 lines, 1 line, so you can change that up. You don't always have to have, like, well, I guess this is 2 of the same, but you can, if you browse it, are you an Angular developer? Or?
No.
Okay, so I was going to say the Angular material docs kind of dive in a little further too on placement of items and like how things can interact with each other. Okay. So, but the material design docs are great for that too. So yeah. If you go to here, I can just pull it up. I'll do this. So I like using this site because, for examples, they're templates. So like here's a blog template. So I'm not saying you have to use it, but here's a blog template using Material Design Lite UI framework. So you have your cards. So these are each cards, the card materials. You see how you have the fab up here. This one has a button, an action button over here with a title. You have an icon with a title here, title and a subheader, image. You have a full width card, so you can mess with widths. The other thing with material design is it's based on the flex grid, whereas if you're used to using Bootstrap, that's just a grid framework. It's where you columns and rows. With material design, I don't know if this one shows it, but I guess a good thing, if you're on Google Plus at all, you know how each post kind of, it's not all in the same grid format. Like you can have, 2 take up the space here and 1 here, so it's on a flex grid format where it can change rows, it can change columns, it can span across. So it's very flexible. So
is the responsiveness built in, or is that something that?
So like, I was trying to be quick. I don't know. I guess the light doesn't have that built in, but I see it.
Do you know if the Bootstrap material design version, does it stick with the grid of the classic?
I've not used it. I looked it up for this because I've seen it before when I was doing other research into material design when I was applying the Angular material framework. So I believe it goes to the flex grid, but I'm not 100% on that because I've not tried to use it. Using the same material design, you have Android layout. So this, I guess you could say a little bit Bootstrap-esque, where you throw the navigation into the, I guess it's all white here. So you throw the navigation into the top right, and then you can have your page, your logo in the top left. You have your menu, and so you see how it's slid over and then everything else grayed out. So that's your transition with intent. So this is, your menu is now bold. You would never open up a side nav and leave this ungrayed out because you're calling attention, it's bold. they click that button. So the intent is they're doing something on that menu now, on that side nav. So that's an example of calling to that. And obviously there's no close, but when you click off, you see how it had that slide transition and the gray faded back to regular. Let's see if I click this. It was very fast, but it had a little ripple in it. You probably didn't see it on this screen. So there was a little ripple in there. It's kind of hard to see here, but if you pull it up on one of your phones, laptops. Oh, and the other thing about material design is it works across platform too. So if you have an Android watch, an Android Wear, material design. Your phone, material design, tablet, and now with the web, because you have these web frameworks. So, any other questions about material design? Comments? Pros, cons? You hate it? Can't wait to use it? You like it? So, yeah, I definitely recommend going through the material design docs to kind of get a better lay of the land. But those frameworks are ready and available, heavily tested. There are lots of other frameworks out there. Not all of them have reached 1.0 status yet, so they're kind of iffy. So I only showed the ones that I know of that were production ready. Cool beans.